Another basic rule of excavation deals with accumulating water. Water changes the entire dynamic of soil conditions. Water is the glue that holds the soil together. Too little water and the soil dries out, causing it to lose its cohesiveness, which promotes various types of trench failures. Too much water turns the soil into slurry, promoting, other types of trench failures. And depending on soil conditions, protective systems alone may not be sufficient in protecting the worker. Too much water, even with protective systems in place, can cause the trench floor to heave or boil, essentially turning the ground into quicksand. There are three popular methods in mitigating water hazard exposure in excavations. One is special support systems, and as we've just demonstrated with protective systems, special support systems alone may be ineffective in protecting the worker based on water saturation, environmental effects, as well as soil conditions. Another is the body harnessing lifeline. This method may have some merit when working above or around the water hazard, but it doesn't do much if the worker has to be in a trench that is collecting water. In a situation like that, all the body harnessing lanyard does is, to be quite blunt about it, is to ensure for an effective body recovery. Not only that, but depending on what the worker is tethered to, that anchor point itself may become a surface encumbrance, promoting a potential cave-in. And couple that with the trip hazard that is the lifeline lying all over the ground, immediately adjacent to a hole full of water and quicksand. Another popular mitigation method is water removal. This is effectively accomplished through the mechanical means of a water pump. The stipulation here is that if the water removal equipment is utilized, then it must be monitored by a competent person to ensure that this equipment is operating properly. If our hole in the ground is actively accumulating water and workers must enter that excavation, then the continued use of a water pump will be necessary to ensure that the water does not compromise the integrity of that excavation, thereby mitigating any hazard exposure to the worker. And something else to keep in mind. If a water pump is to be continually used, then the potential for a hazardous atmosphere has to be taken into consideration. If this is the case, then continuous air monitoring in that excavation will be required. Everything starts to get interesting at a depth of 4 feet, because this is the depth that OSHA really starts taking a keen interest in excavations and trenches. For starters, since this is when holes in the ground start attracting so much attention, you need to have an excavation and trenching competent person on site, so that they may supervise all of the work being planned and conducted. This is to ensure that all the logistical particulars are being followed, and that the workers going into these excavations are being safe about it. Also starting at 4 feet, there must be an established means of entry and exit. Climbing the wall does not count. The two most popular and acceptable methods are the ladder and the earth ramp. When using a ladder, it cannot be a step ladder. It must either be a straight ladder or an extension ladder. Now, if bulk becomes an issue with the extension ladder and the company rules and ladder manufacturer permit it, the extension ladder may be separated. If it is permitted to be separated, then make sure that the section you are using can be used independently. Most oftentimes, it is only the base section that can be used as the standalone ladder, not the fly section. I imagine this has something to do with the fact that the fly section is structurally smaller, so it may not be designed to independently support the ladder's full capacity. But it is also narrower, so it's going to have a tighter stability platform, making it much easier to tip when using it. And of course, whenever we are using a ladder, then it must be extended to at least 3 foot above the lip of the trench. The purpose of this is to assist the workers in maintaining their balance as they mount and dismount the ladder, reducing the potential of a fall. Another acceptable means of getting in and out of the trench is the packed earth ramp. The angle of packed earth ramp is dependent on the soil type and soil conditions, but regardless of how dense and great the soil may be, the packed earth ramp cannot exceed a 45-degree incline. That way, should workers have to exit the excavation in a hurry, they're not fighting and clawing their way out, which would only serve to delay their self-rescue. When an emergency hits, workers must have the ability to immediately evacuate that hole. And that plays into the earth ramp having to be packed. We don't want workers having to negotiate running soil or quicksand while trying to save their own life. When setting up all of these entry and exit points, they must be positioned so that a worker is never more than 25 feet away from one at any given time. Now, I mentioned that holes get a lot of attention starting at 4 feet. This being the case, once an excavation or trench reaches a depth of 4 feet and workers will be entering that excavation or trench, then a trench log must be filled out. This not only guides the workers on site through the logistics involved, but it documents all of those logistics as well, in the event that any, shall we say, concerned parties arrive on site and would like to discuss said logistics.